Welcome to Resin Chem Tech. Today I'm going to take this neon rope tube that I took a look at in my last video and compared to LED channel, and I'm going to use it in my first outdoor install. It's also going to be my single largest LED install. Now, as always, check the video description. You can find links down there to a written version of this. We'll have parts list and wiring diagrams and more photos, kind of a step-by-step guide. You can also use the links here along the timeline to jump around in the video if you like to a particular part that you might be interested in. With that, let's get started. So this is the general game plan. We're going to be installing our BFT neon rope tubing with our LEDs around the top edge here. Each side of this is just under 12 feet. That'll be somewhere a little over 200 pixels, so therefore we're going to need to do power injection to each of the four corners. This light fixture will come down and we'll be putting up a waterproof enclosure that will contain our power supply and our controller. The light fixture, however, is controlled by a wall switch. Now, since we want to have continuous power to our strips for automations and control through Home Assistant, we also want the switch to be able to turn the lights off and on. We're going to be installing a Shelly 1 PM relay behind this switch. So since each side here is just a little bit under 12 feet and both our BFT neon rope tubing and our WS2812B pixel strips only come in maximum lengths of 5 meters or a little bit over 16 feet, we're going to have to, we can't do one continuous run. And since I need to do power injections at each of the corners, it just made sense to me that we'll do a straight run for each one and we'll do our power injections in each corner. What I've decided to do is I've printed some little 3D boxes that we'll look at these a little bit more later, that I'll be able to put in each corner to where I'll be able to do my power injection and hide my wiring. In addition, anywhere that there might be exposed wiring, I'm going to have some of this white conduit, and I actually managed to find some white heat shrink tubing so we can try to make sure that no wires are exposed anywhere. I did print some additional 3D parts that I'm going to use in this project, and I'm just going to show them here because they're going to be easier to see than after I get them mounted up on the porch. But I have 3 boxes for my corners, and this is where we will connect the corners of those neon tubes that come together. We will also do our power injection in these. This large one will be mounted right above the enclosure and will contain all of our different connections for our runs for our power injections out to the corners. I did print some additional end caps. These are the ones that came with the tubing. Unfortunately, there are only 2 for every 5 meters. Since I'm going to be cutting these into sections, I needed some additional end caps. I also printed some additional mounting clips on here, and I added a back bracket where I'll be able to put my power injection wires to keep them kind of neatly tucked away and hopefully hidden. And finally is just the enclosure box for our WLED controller. Okay, the first step, after of course assuming that the power is off, is to remove this old light fixture off the wall. Okay, we have no real surprises here. We've got our ground, our hot, and our neutral, and it looks like we have plenty of scrap wire, so we're going to go ahead and disconnect and remove these, and we'll cap those wires off for now. Okay, so one of the first challenges I'm going to face is mounting of my enclosure. And unfortunately, this was the only thing I couldn't get in white. They do make enclosure boxes in white, but none that were going to be big enough to hold my 5-volt, 60-amp power supply and my controller. Obviously, this does not come with any external holes, but I think I'm going to be able to mount this right here and possibly even use the screws for the mounting plate behind here and screw it securely into that. And then we will have a hole that's coming out of the top, and we'll use that white conduit to run up to the start of our strip, and will also be all of our power injection wires. Okay, now we've got the box mounted to the wall. I will admit it was a little hard to get these lined up with the holes behind them because there wasn't much room to see, but it's on there pretty securely. Now I have to take this back down again because we still have to cut the holes for our AC line in and for our wires going out of the top. Plus, when I mount this permanently, I actually will put a bead of caulk around it here to make it a little bit more weatherproof. Okay, we'll take a quick look here where I am with the enclosure now. This back plate obviously comes out, and we're able to mount the power supply using M4 screws, which were built into the power supply. This obviously is going to be raised and mount in these screws here. So this will mount in here. We'll leave room for AC wiring to come around the back and connect to the power supply here. So this is how everything will basically look once the final wiring is done. The only thing missing here is, again, is that incoming line or AC power. But our primary 5-volt power, we are going to run through a fuse, an inline fuse here. We'll run our primary 5 volts ground and our signal wire out, up through conduit. We'll go up to the point where we would then distribute it to our power injection points. And again, here's our controller and the 2 wires for our push button at the bottom. Again, we'll take a closer look at this once we get it actually mounted up on the wall, but everything does fit nicely in here. And so I'm not going to cover the step-by-step process of building the WLED controller here. I have another video that shows this step-by-step, and you can find a link for that up in the corner of this video and down in the video description. But there is one difference between that video and what I'm doing here, and that's the fact that in this case, I'm using an ESP32. Now, for most of the smaller projects, anything up to maybe a couple hundred LEDs, I recommend the 8266 is fine. But in this case, I need the extra processing power, because according to the official WLED website, you shouldn't run anything more than around 500 pixels off of a single pin on the ESP8266, and we're going to be somewhere around 800. Now, it says for the ESP32, you can expect very good performance for anything up to about 800 LEDs per pin. Also, in addition, the ESP8266 can only run somewhere around 15 frames per second at 1,000 LEDs, while the ESP32 at 1,000 LEDs can run at around 70 frames per second. So we're going to get much more performance, especially on our animations, less likelihood of flicker and problems with those by using the ESP32. And just because the ESP32 is a little bit larger, I'm going to be putting this on a little bit larger electro cookie board. So that does make some slight differences in the wiring. It actually makes it a bit easier. But I will have a wiring diagram of this particular version of the controller with the ESP32 in my related blog article, which you can find down in the video description. So with that all done, it's time to move on to cutting our neon tube and preparing our LEDs. Now, I covered cutting of this tube and installing the LEDs in quite a bit of detail in my previous video, which you'll find a link for up in the corner, where I compare this to LED channel. But the one thing to note is that there's a pull string that runs the entire length of this tubing, and if you're going to cut it into segments, you want a little bit of pull tube at each end of the cut. So what I found is by using a small screwdriver and just being a little careful when I cut through it, I could pull that string up. Now, if you happen to cut through the string, you could probably use a small pair of tweezers or something to pull a little bit into each end, but it's a little bit easier just to make sure that you don't cut that. Otherwise, the tube cuts very easily with a box knife. Now, I do like to add a little bit of masking tape to both ends of this just to hold that string so that I don't inadvertently pull it out of one end. Although it's no big disaster if you do. I actually did it once. I actually was able to use some 18 gauge wire, tie the pull string to that, and feed it back through the tube. Next up was cutting the LED strips. Now, what I did do here is I actually cut them 1 or 2 pixels shorter than the length of the tube. That way, once I attached my wires and soldered those on, those solder joints would actually be back up slightly inside of that tube, and there would be room to put the end caps on. But we're not done with the LED strips yet. The next thing we have to do is we have to remove all of that adhesive off the back of the strips. Now, after my last video where I struggled a little bit to get some of that adhesive off, thanks to some of my viewers, they gave me some other ideas to try, and I found that this works about the best. I actually used my wife's hairdryer, don't tell her, on a medium setting just to slightly warm that strip. I do have a heat gun, but even at its lowest setting, I felt like it was too warm. But by just warming this gently and kind of trying to pull that tape straight up, kind of at a 90-degree angle, and working your way slowly down the strip, it didn't leave hardly any adhesive behind, and any little bit that did get left behind was easy to remove with a rubber eraser. Now, this was a time-consuming process. I would say that each 12-foot strip probably took me 15 to 20 minutes to get this adhesive back off. Okay, now I'm going to go ahead and solder my leads onto one end. Now remember, we can only solder onto one end at this point because we still have to pull this through our neon tube. So by putting these on one end, we'll be able to pull it through the neon tube to the other end, attach our wiring, then use these wires to basically, almost like a pull string, to pull it back underneath so that both ends of our solder joints are within the neon tube. So, okay, before we actually pull the LED strip through our neon tubing, I do want to do a quick bench test. And you'll see here I'm actually using the power supply and the controller that will be going in our enclosure box. I've got it temporarily hooked up, and I've got a switch here as well. Just want to make sure that nothing got damaged with the strip before we go and pull that through there. So we'll flip the power on. There we go. We can check our strip and make sure that all of our LEDs are lit all the way to the end. So everything looks good with that strip, so we can go ahead and pull it through our neon tube. Now, pulling it through a 12-foot length was much more difficult than the 2-foot piece that I used in my first video. But I tried to get the tube and the LEDs laid out as flat as possible, putting the LEDs on ceramic here so they didn't snag on the carpet, then tying a little knot around the first pixel and feeding the edge into the LED tube. Okay, took a little bit of coaxing on the other end to get that string past the start, but it is pulling through here. I am trying to pull gently because I obviously don't want to break the string halfway through. Now, one of the challenges here was trying to keep that tube flat. It kept wanting to roll over on its side and kind of curl up. In addition, it would occasionally get snagged on the other end, usually every 30 pixels where there was a bigger solder joint. So that would mean going back down to the other end, wiggling that past, and back and forth, back and forth, back and forth. This is where a second set of hands would really be helpful. There we go. Okay, so now I've got the other end through. Here I'm right at the very end, right there are my solder joints, so I'm going to end up pulling this a little bit further in. And then if we come down here to the other end of our tube, see I have a couple of pixels already sticking out. So yeah, I did leave this a little bit longer. What I'm going to do is determine about where I want to cut this. I'll go ahead and pull that through, cut off those pixels, solder my wires to this end, then I'll be able to use the wires at the other end to pull it back so that both ends and my solder joints are inside of the tube. Okay, our first tube is now done. I ended up cutting off 2 pixels off the end of the strip, so I was able to pull both of them back inside of these end caps that I went ahead and installed. And I was smart enough to go ahead and label not only the position of this tube, but the data flow direction, because now I can now no longer see the LEDs. But what I forgot to do was count the number of LEDs. So I'm going to hook this back up to our bench test so I can get a count, because I'm going to need to know a total count of LEDs for WLED when it's all said and done. So once all of my neon tubes were built, there was one final thing I needed to do inside the house before I moved out to the back porch for the install. So next I'm going to install my Shelly 1 PM behind this light switch. And remember why I have to do that is if I don't put this relay back here, anytime I flip this switch off, it's going to kill the power to the power supply and the WLED controller, and there'll be no way to turn it on with automation. So what people tend to do is they tend to flip this on and put tape over it, which now removes your ability to turn those lights off and on with a switch, and we don't want to remove functionality. Now there are 2 different ways to wire this. I can wire this so that this power supply and my WLED controller are always on, or I can wire it up so that the Shelly will turn on the power supply, which will then boot the WLED controller. I'll cover both of those now. So I did want to quickly cover these 2 different wiring methods because they both have pros and cons, and they could impact how you decide to implement automations in Home Assistant. So in this first scenario, our power supply, our outdoor power supply, is always going to be powered on. You can see this is directly connected to our line and our neutral. So this is always going to be on regardless of what we do with this switch. But as a result of that, it means our WLED controller is also always going to be on and booted up and ready. Now that doesn't mean the LEDs have to be turned on. We can turn the LEDs off with the controller, but the board and the power supply will always be on, and even the LED strips, when they're technically turned off, actually still draw a little bit of power. In this case, we control those LEDs with the switch by using the Shelly 1. The Shelly 1 will detect when this toggles, and then we can use automation to send a command from the Shelly 1 to our WLED controller to tell it to turn the lights on. This is going to be a faster response time. We still have to have at least one automation for the Shelly 1 to tell the board to turn on when the wall switch is flipped, but it will be the quicker way. Now in the second scenario, you can see that we now use the Shelly 1 to actually control the power to our power supply and our WLED controller. So in this case, when we turn the switch off, it's actually going to kill the power to everything outdoors. This means we're going to be able to save some energy, and can also be a safety precaution if you've got really nasty weather and you just as soon shut the power off to everything that's outdoors. Now, the drawback to this is when we can't talk directly to the WLED controller when the power is shut off because it's not booted up. So in this case, we have to power on the Shelly, which will power this on, and boot up the WLED controller. That means we're likely going to see a delay in terms of our automations, and any automations we send that don't involve the switch are going to be two-step. First, we have to toggle the Shelly relay, then we have to wait for this board to boot up before we can send additional commands to the WLED controller. So this is probably going to introduce some lag in terms of our automations, and we'll take a look at that just a little bit further along in the video. So I've decided I'm going to go with the second option here, so that when I turn this switch off, it's actually going to power everything down outside. I just feel that that's safer. Yes, it's going to be an extra step in my automations, and it might introduce a slight lag just because of the extra step. Powering this on, which powers this on, which takes a second or two for this to boot. But I think it's a safer way, and if the delay is too significant, I can always go back and rewire it the other way. Sometimes these can be a little tough to get in your boxes, depending on how much wiring is there. But there's quite a bit of space behind this particular switch, so I think this is going to go in pretty easy in this case. Okay, just a quick look to see the Shelly 1 is now installed. Again, there was plenty of room in this box. It was actually one of the easier Shelly 1 installs that I've done. But now this switch will still control that outdoor junction box, light fixture, or my LED lights when I turn that off and on. But in addition, regardless of if this switch is turned off, the Shelly relay will now give me the ability to control the outdoor power to the junction box and to my LED lights via Home Assistant and Tasmota. So after the Shelly 1 was installed, I did go ahead and mount that outdoor junction box with the power supply while I had the power turned off. Okay, our box is mounted, so it's time for a quick overview here. Everything is mounted up on the wall. Again, our mains power is coming in from the back. Our 5-volt positive and negative is running up through the conduit. There's our fuse, our controller, and again the push button here at the bottom. And if we follow this conduit up to the junction box, so for right now I just have the first strip mounted and wired. I don't have any power injection running yet, but I do want to just do a quick sanity check here to make sure everything is wired and working as expected. So we will flip open the door here, and we're going to flip on the switch, come back out, take a look, and we have light. It is taking a few more mounting clips. It's possible to avoid sagging. You can see a little sag right there. So I think I'm going to have to fire up the 3D printer and put some more clips to try to keep that from sagging. But the good news is everything is wired and working. That is just temporary up there right now. Again, no power injection is run yet. Next up, I will run my power injection and move on to mounting the strips on the other three sides of the porch. So while I do want to thank BTF Lighting for supplying me with this neon rope tube and the WS2812B pixel strips, I do need to be honest in some of the challenges that I faced in mounting this neon rope tube. One of the first challenges, and I kind of mentioned this when I was installing the LED strips, is the tendency of this tubing to want to roll or twist and flip. And that's just from being, packaged. But even though I left this laying out for multiple days and even tried to bend it back, it still always had a tendency to want to twist on me. So that was the first challenge, especially when trying to hang a 12-foot long strip. Next, these are the clips that came with it. Unfortunately, there were only 6 clips per about 16 feet of this, so that meant one clip about every 2.5, 2 3/4 feet, and that was definitely going to leave some sag in between, so I was going to need more clips anyway. So when I designed my 3D printed clip, these are very, very tight to try to get on. I mean, you've really got to kind of pry and squeeze to get them on. So the idea behind mine when I mounted them is that once they were mounted, you would be able to take the tube and more or less just hang it into these clips. But it does still have a tendency to let that tube want to twist, which you wouldn't have with these particular clips. The other thing I wanted to do was put this tab on the top. Since I knew I was going to have to run power injection along, I wanted to do that. But when the tube was mounted in there, this was close enough to the wall that I actually had to feed my power injection all the way along. And to be honest, once it was in there, and you'll see this in a minute, you can still plainly see the wire. So I didn't like that option. The good news was that I had enough slack in my clip that I was actually able to take my power injection wires and push them down behind the LED strip. That made it, the wires not only hidden, but also made this a little bit tighter in this clip. Installing these were definitely a challenge. For the long strips, it definitely took two people. You couldn't put one end in of these particular clips because it would want to twist it and fall out. So it did take two people at each end working towards the middle to get these mounted on the wall. Okay, while it's taken most of the day, we now have two strips complete, including power injection to both of these other corners. As part of what took so long, I ended up rerunning the power injection wires 3 times before I was happy. But they're pretty much hidden now. They're actually running behind the tubing. I also discovered that I'm going to have to redesign and reprint these junction boxes, at least these small ones for the corners, as they're just going to be too small to hold everything. So I'll be redesigning those and reprinting those tonight, and we should be able to get the last 2 segments up tomorrow. Well, it's taken the better part of 3 days, but the project is finally complete. There was a lot of changes along the way, some redesign and reprinting of 3D parts, dealing with unforeseen issues. But the good news is we are, I think, 815 LEDs total, and power injection at all 4 corners. Again, we have the wall switch inside. We do have the local button control here. Again, we'll turn our lights off and back on, and eventually we'll also be able to change effects. So before I do a wrap up and my final thoughts on this, let's take a look at a little bit of video at night. Okay, you might be able to tell from around the scenes here, it's almost completely dark out now. I'm on the porch. I have the LEDs on, just on white at about 50%, and it is plenty of available light in here to be able to read, to play cards. And again, that's only about 50% brightness. But of course, we don't have these out here just for the white light. We naturally want to be able to have all the different colors. Try one of those out here. And again, so we have the full plethora of WLED at our disposal. I'm actually running the WLED app on a tablet. We also have the availability through Home Assistant. Okay, so I thought I would come out and film this a little bit from outside the house. Sorry, it's a little breezy out here if you're hearing some wind noise. Just to give you an idea of what it's going to look like somewhat from a distance, again, or maybe for the neighbors across the pond over here. You know, so we have the ability that to tie this into Home Assistant and to do something like, to say if motion was detected, have the lights come on with some kind of effect similar to something like this. Definitely get someone's attention, make them think maybe once or twice about proceeding any further. The ability to have those different effects for different holidays, different seasons, whether it be the 4th of July or Halloween or Christmas, you would have that. But again, just the ability to have that, you know, generally solid light, to have some kind of ambiance or mood lighting, or again, you know, obviously just to have the normal white light. I do want to go back and address the delay that's introduced by using that Shelly 1PM, especially the way that I've got it wired. And this will apply to you as Home Assistant users, especially if you want to use automations. So as you recall, I opted to wire my Shelly 1 so that it actually killed the power to the power supply and therefore the WLED controller. Now that is going to introduce a bit of a delay. As we turn the power on, WLED still has to boot up. Right now, WLED has a default setting of booting up into just white lights. So let's just take a look by default before we look at any automations, how long this actually takes. So you can see it already takes about 1.5 seconds for that WLED controller to boot up once it receives power. So let's take a look at how the 2 different methods compare, with the WLED controller always being on versus having to wait for it to boot up when we try to issue an automation to turn on the lights and to set an effect. So to test our 2 different methods of wiring that Shelly 1, I've created 2 different scripts. So the first script is going to be a direct call to WLED controller. That's going to assume that the power supply and the controller are already powered on or powered on all the time. So you can see here I've already got the Shelly 1 relay is already on. It's a very simple script. All we have to do is make one service call to turn on the WLED strip, and we can pass the brightness and effects at the same time. So let's click this and see how quickly our lights respond. There you go. You can see that the lights came on again in about 1 second. You can see the WLED controller came on here, and they came on with the candy cane effect that we passed to it. So now let's test the other Shelly 1 wiring scheme, which is the way I currently have it wired, in which case the Shelly 1 relay actually cuts the power to the outdoor power supply and the WLED controller. And you can see that here. The Shelly 1 is turned off, and our WLED controller is actually offline. It can't even be turned on because it obviously has no power. So in this case, when I call this script, it's actually going to have to be a two-step script. First, I'm going to have to turn on the Shelly 1, and then I can issue the command to turn on the WLED and set the effect. Now, since I know from the previous testing there was about a 1.5 second delay between the time when power was applied and the LED lights came on, I've added a 2-second delay here. So let's fire off this script and see what happens. Okay, our lights have come on, but you'll notice that no effect got applied. What I realized is it takes significantly longer for the WLED controller to mount to the Wi-Fi so that additional commands can be sent. So let's take a little bit closer look at that delay. So here you can see my WLED controller is offline. So what I'm going to do is I'm going to turn on the Shelly 1 relay and see how long it takes before WLED controller shows that it's available within Home Assistant. So there you can see again, it took, in this case, about 6.5 seconds. Now I've seen some variations of that depending on how quickly it's able to join my Wi-Fi. At this point, I'm going to up that delay to 10 seconds and see if that works for our automation. Okay, I've now added that 10-second delay into our script. So let's launch this script again and see if we can get our effects to come on after a 10-second delay. Here we go. I'm going to click. And if you watch down here on the Home Assistant side, again, you're going to see that WLED controller come back online. There we go. And then there are our effects being shown. So a 10-second delay seems to work. So you may want to think about what types of automations you want to use to determine how you might want to wire that Shelly. If you're going to tie this to something like sunrise sunset, then a 10-second delay is no big deal. However, if you want something that reacts to motion, 10 seconds may not be quick enough, and you may need to think about either changing the way your automation works or rewiring that Shelly to option 1. So what are my final conclusions? Well, this is a great product, and it does offer some nice diffusion, and of course the IP67 waterproof, but they do take a lot of extra work, at least compared to aluminum channel. Again, where mine are situated, they're not going to be exposed really to direct rain. So if I were to do this same exact project over again, would I use these rope tubes? I don't think that I would. Again, just due to they're already somewhat protected and everything was flat, straight runs, I do think I would use aluminum channel if I were to do this project over. So just another reminder to check that video description. Down there you will find links to a written version of this project that will have my complete parts list, wiring diagrams, photos, and more information, along with links to other videos for things like building your own WLED controller. And if you found anything in this video that you liked or found useful, hit that like button for me. That lets both me and YouTube know that others ought to see this video. If you'd like to see more of my videos, hit that subscribe button and ding the little bell icon if you want to be notified when I release new videos. As always, I would like to say thank you for watching, and I hope to see you soon.